Okay, this is lesson 3B. Lesson 3B is all about percents. And percents are one of the most commonly used parts of mathematics in the real world by regular people. So we'll spend a little bit of time on that, hoping you can become somewhat proficient. So we're going to have regular percents that we can solve with a proportion or an equation. There'll be a percent change with markups and discounts and other percent change problems. Commission, sales tax, simple interest, and then a little bit of probability at the end because you can express probability as a percent. So in the beginning, let's just talk about like what a percent is. So the word percent means per, like out of, right? Out of, like miles per hour is like miles over hours. So per is like out of. Cent is out of is 100, so it's like any number out of 100. So 64% is 64 out of 100. Now, when we convert percents to fractions, be sure to reduce the fractions to simplest form. Always reduce fractions to simplest form. So whatever the greatest common factor is there, so let's say 4, that's going to be 16 out of 25. 125% is still 125 out of 100. Remember, it's out of 100. Even if it's more than 100%, it doesn't matter. It's still out of 100. So reducing that would give you, let's reduce by 25. So 5 out of 4. That's okay. 5. If you divide 5 by 4, then you get 1.25. That reminds me, we need to also make these as decimals. So making this as a decimal, 64%, 64 out of 100 is 0.64. 125% is 1.25. And you could take the fraction and divide it to get the decimal. 5 divided by 4 is 1.25. Or, since the percent means out of 100, we could just take 125 divided by 100, which moves the decimal point over 2 places, so 1.25. So 37.5% would be 0.375. For that same reason, 2 decimal places, because 2 decimal places would be 100. Divided by 100 moves the decimal point 2 places to the left. Now that fraction, if you wrote 37.5 over 100, that's harder to reduce because we have a decimal in the numerator. So it's easier on this one to make the decimal number into a fraction. And this is tenths, hundredths, thousandths, so that is really 375 thousandths. And then we could reduce that. So to reduce 375 thousandths, common factor, let's try 125. So I'm going to divide by 125. 375 divided by 125 is 3. Let's try 1,000 divided by 125 is 8. So that is 3/8. Remember, always write your fractions in reduced form. 3/8. 5%, remember percent is over 100, so that's 5 over 100. In decimal form, 5/100 is 0.05. You have to have that 0 in there. Otherwise, it's not 5%. We don't want 50% to be confused with 5%. 0.05 is 5%. And we can reduce that fraction also, divide by the top and the bottom by 5. So that's going to be 1 over 20. 3 1/3%. This is a tricky one because 1/3 itself is a repeating decimal, 0.333. So 3 1/3% is really 3.3 repeating percent. And if you put, let's say if you divide 3.3 by 100, that's 0.0333. Okay, now as a fraction, this is going to be a little harder. So we have 3 1/3%, which is 3 1/3 over 100. We don't want to leave 3 1/3 as 3 1/3. Let's multiply the top and the bottom of this fraction by something that will eliminate our fraction. So let's multiply by 3. 3 1/3 times 3. Go ahead and multiply that together. That would be 10. 100 times 3 would be 300. So it's 10 over 300, which is 1 over 30. So sometimes it's a little tricky to get the fraction into reduced form, but never, never, never leave a decimal in a fraction like this. See, that's no good. And never leave an improper fraction in a fraction like this. Don't do it. Always write the reduced fraction, which is one number over top of another number, a whole number over another whole number, so that it can be a nice reduced fraction. Convert each fraction to a decimal and to a percent. Okay, so every fraction is a division problem. So this little fraction bar is division. So just take 5 divided by 8. Now, some of you maybe want to do that by hand, but I can't do it right now because my mind is just not in it. You ever have days like that where the simplest things you want to get help with? Okay, so I divided that. I got 0.625. Now that's my decimal. If I want the percent, I have to have a number out of 100. So that would be the opposite of what we were doing up here. See, up here we were dividing by 100, so now we're going to multiply by 100. 62.5%. Okay. 2/3. 2 divided by 3 is 0.666 repeating. It's okay to write the decimal that way, as repeating. If you're rounding it off, it would be 0.667. But we typically don't want to round it off. So we're going to leave it as a repeating decimal with a repeating sign. 2/3 is a better fraction than a repeating decimal, but as a percent, multiply by 100. So that's going to be 66.6 repeating. The 6 is still repeating. Percent. Now here's something interesting. Since 0.6 repeating is the same as 2/3, see right here, look, 0.6 repeating is the same as 2/3. We're going to take this 0.6 repeating right here and change it into 2/3. That is 66 2/3%. It's closer to 67%, but it's 66 2/3%. If you're rounding it off, it wouldn't be 66%. 7/4 is 7 divided by 4. 7 divided by 4 is 1.75. Notice that 1.75 is larger than 1, so that when we multiply that by 100, it's going to be 175%. It's going to be a percent bigger than 100. Numbers larger than 1 turn into percents that are larger than 100. 100% in decimal form is equal to 1. 100% is equal to 1. Okay, let's see. So we're going to find some percents of a number. Now, all of these problems of finding simple percents, we can use an equation or a proportion. In certain problems, I prefer using an equation because it just, to me, makes more sense. You can choose which way you like, but here's why I would use an equation. See the words what number? That's like my variable. What number? X. See the word is? That's my equal sign. 45% of 80. Let's talk about this word of, because we use it all the time in math, and it always represents the same thing. So if you take a group of students that had, let's say, 12 students, and half of the group would be how many? 6. So notice that we said half of the group. So what we did when we did that is we multiplied by 1/2 times 12. So that's half of 12. So of kind of means that we're multiplying. It's pretty common. So 45% of 80 is going to be the decimal form of 45%. Whenever you put a percent into an equation, you need the decimal form of the percent. So 0.45 of 80 is times 80. And in this one, we can just multiply 0.45 times 80, whatever that is. 0.45 times 80, you can hear my calculator keys here, 36. All right, let's try the next one. 72 is 80% of what number? All right, so I'm just going to write 72. Is, that's my equal sign. 80%, 0.80. Of what number? Times x. What number is the x? So now when I solve this one, I have to isolate the x, canceling out the times 0.80, so I'm going to divide by 0.80 on both sides. And it's going to be 72 divided by 0.80. Notice, watch what happens when we do this, divided by 0.80. We're dividing, but we get a larger number. And check to see if your answer makes sense. Like 72 is 80% of some bigger number. 80% of some bigger number is 72. See, that would make sense. So when you divide by a decimal that is smaller than 1, you get a larger quotient. All right, 56. 56 is, that's my equal sign, what percent? Now this time we have a missing percent, so that's my x of 80 is times 80. So now this time I'm going to divide by 80. Now when I get this, 56 divided by 80, I get 0.7. Now that's 0.7 is the decimal form of the percent that I want. Because remember, go back to problem A, whenever we use a percent number in an equation, we have to make it into the decimal. Like 45% is 0.45. Okay, so this one we got the decimal form of the percent from the equation. Now we have to turn it into the percent. So how do we turn that into a percent? Multiply by 100. So x would equal 70%. Okay, so if we ask for a percent, be sure to give your answer as a percent, not as a decimal. Because I don't want you to think it's 0.7%. That's really small. Okay, and question D, 125% is a decimal, 1.25 of times what number, there's our x, is, that's our equal sign, 80, and there's our equation. See, these problems are easier for me to solve by an equation because they translate directly using of for multiplying and is for our equal sign. So now we can divide by 1.25. Now some other problems we will solve with a proportion, and we'll see some of those here in a minute. So 80 divided by 1.25, 64. 125% of 64 should be a larger number. It is, it's 80. Okay. Next, let's try this. Here is the label off of a breakfast cereal. One serving of cereal provides 85 milligrams of potassium. Let's see, where is that? It's right here. Okay, this is about one serving. 85 milligrams of potassium, that says right there. Which is 2% of the recommended daily amount. Here it is, 2%. What is the total recommended daily amount of potassium? Now, this is not written in the same way that those other problems are until you get to the last sentence. You can take a look at the last sentence and maybe translate that into an equation like we were doing. Because we have the word is, we have the word what, but it doesn't say something like percent of something. So in this one, I would probably write a proportion. Okay, so a percent as a proportion always goes like this. A percent number is always out of 100. And what that is describing in most cases, it's describing some part of something out compared to the total. that is our typical percent proportion. Percent over 100, because the percent is always out of 100. So in this case, we have 2% of the recommended daily amount. So we're going to take 2 and put it over 100. Now in this case, we're not using the decimal form because we're using 100 in our proportion. Okay. Now, that 2, this is important here because remember in proportions, the left side and the right side have to match. Okay. So that 2 is 2%. That is what potassium is giving you. Okay. Potassium is also giving you 85 milligrams. Okay. So we have 85 milligrams. That's the part that is potassium. And we want the total. What is the total? So you look at the question. What is the total recommended daily amount of potassium? That's what we don't know. So that's our variable. You can use X if you wish. And then after you find that, check to see if your answer makes sense. So now remember in proportions, cross multiplying. So that's going to be 2t equals 85 times 100. And then divided by 2. So t equals whatever 8,500 divided by 2 is. And that should be 4,250 milligrams of potassium. Okay. So does that make sense? Because 85 milligrams is a really small percent. So the total amount would be so many times larger. Yeah, I think that makes sense. Like 50 times larger. Okay. Some of you in your jobs after school, after college, after graduation, will involve commission. Possibly. So there are some commission applications here. Now, these commission applications are not like percent increase and decrease problems. If somebody earns money by commission, then it's not necessarily increasing or decreasing the amount of the car or the house or whatever they're selling. It's just the amount part of the total that they would be making. Okay, so Bill's a realtor. He received 3% commission when he sells a house. How much commission would he receive for selling a house that costs $225,000? Well, he's going to receive 3% of $225,000. So it's pretty much just a multiplication problem in this one. So I can make an equation, but that would be his commission would equal 3% of the total. So if you're going to have an equation for these, then it's the percent commission as a decimal times the total sales equals the amount of commission. You can also do these by proportion. All right, so 3% of 225,000 would be 0.03 times 225,000. Don't leave the zeros off because Bill would not like that. 0.03 times 225,000. 6750, that's $6,750. And you might look at that and go, wow, just for selling one house? Yes, and that's pretty good. But keep in mind that there are some months that Bill might not sell a house. Okay, Nancy works at a retail home goods warehouse store, and she earns commission on her total sales. She sold a stove to a customer for $1,450 and earned $87 in commission on that one sale. We're looking for her rate of commission on this one. So we're missing the percent. So if you recall before when I said we're missing a percent, sometimes I like to use a proportion. I would on this one because I have the amount that she earned in commission. So the percent of her commission over 100 would equal the amount of her commission, $87, out of the total sales, 1450. And I would make a proportion like that. Okay, you can also do this by equation. Okay, so if you cross multiply 8,700 and then divide by 450, 1450, sorry. That should be 6, and that comes out to be 6 exactly. Now we don't move the decimal point on this one, because in a proportion, if you use the 100, you're automatically adjusting for that 100. So that is 6%. That is 6 out of 100. Ben decided to go to work as a car salesman, and he was told his commission would be 2.5% of the sale price of the cars that he sells. He was so excited to have sold his first car. His commission check was $587.50. What was the sale price of the car? Okay, you can also do this by proportion if you want to, but this is 2.5% of the sale price, and we don't know the sale price of the car. So if you're writing an equation, it's going to be 0.025 times X, that's his percent commission times the price of the car, equals the amount he made in commission, $587.50. With a proportion, that would be 2.5 over 100. And the amount of the car, which we don't know the total for the car, but we do know his commission is $587.50. So either method would be fine, and in each case, you should get X to be 23,500. It is a dollar amount, so put a dollar sign on there because it's the sale price of the car. Simple interest applications. These you'll probably find easier than the other problems, because there is definitely a formula that goes with simple interest applications, and it is I equals PRT. Now you have to know what these are. So the I is interest earned. Now the interest earned is in dollars. So that's dollars interest earned. The reason I mentioned that that's dollars is because we have some other interest in here. The P is the principal amount invested. Principal invested. Or borrowed. So it could be the amount that you borrow or invest. So if you put $500 in the bank, the principal amount invested is $500. If you borrow $300 from your brother-in-law and he wants to charge you interest, then the principal amount is then $300, because that's how much you borrowed. The R is the rate of interest, not to be confused with the interest earned. The rate of interest. Now, the rate of interest is our percent, but this is an equation, so it's got to be in decimal form. So if the rate of interest is 5%, then you wouldn't use 5 in the equation, you'd use 0.05, the decimal form of 5%. Oh, I should use 4. 4 here would be 0.04, the decimal form of that percent. And T is time in years. So the time has to be in years with this formula, time in years. So if you borrow $300 from your brother and he's going to charge you 10%, then make sure that if you pay it back in 6 months, that you're not really paying for a year's worth of interest. It's not really 10%, then it's 10% times a half. Okay, let's see if we can use that formula on some of these problems here. Nathan deposited $12,500 in our bank account. Ooh, Nathan and her bank account. No judging. Where it will earn 4% simple interest. How much interest will Nathan earn after 5 years? Okay. So we're looking for how much interest Nathan will earn. So I is our unknown. Principal amount invested is $12,500. The R is 0.04. I'm going to use parentheses here. for multiplication. The t is 5 years, and all we have to do is multiply. Okay, let's do that. 12,500 times 0.04 times 5, 2,500. What could be easier than that? Okay, well, sleeping is a little bit easier than that sometimes. Not all the time. Okay, let's try 2. Lauren lent his brother $3,000 to help him buy a car. In 4 years, his brother paid back $3,000 plus $660 in interest. What was the rate of interest? Okay. So in this one, the question is, what is the rate of interest? So we're looking for the R, which means everything else has to be known. So I need to know the interest earned. Oh, because the I is interest earned. That is $660. I need to know the P, the principal amount. In this case, it's borrowed $3,000. The rate of interest, I don't know. That's my unknown here, R, in 4 years. So let's solve that equation. I'm going to multiply 4 times 3,000 and then divide 660 by that number. Okay? 4 times 3,000 would be 12,000, and 660 divided by 12,000 is 0.055. Now, since that is 0.055, write that as a percent. So that would be 5.5%. Okay. Sean's new car loan statement said he would pay $4,866.25 in interest from an interest rate of 8.5% over 5 years. How much did he borrow? Okay, so the question is, how much did he borrow? The amount he borrowed would be the principal amount invested, so P is the unknown in this one. So I have to know everything else. I need to know the interest earned. The interest earned by the bank who lent him the money to borrow the car, to buy the car, is $4,866. That's the I. 4,866.25. The P is unknown. Put it in there anyway. The interest rate, 8.5%, is 0.085 for 5 years. I'm going to multiply these together first and then divide by that total to find P. So 0.085 times 5 is 0.425. I'm going to divide that into $4,866.25. And I should get $11,450. So P equals, put a dollar sign on there, $11,450. Okay. Adriana invested $4,500 for 8 months. 8 months. In an account paying 5.25% simple interest. How much interest will she earn? Okay, how much interest will she earn? That's the I. So we're looking for the I in this case. We should have the P, which is $4,500 invested. The R, 5.25%, 0.0525. The T is time in years. We have 8 months. 8 months is 8/12 of a year. It's like a decimal part of a year or a fraction of a year. And if you want to reduce that fraction, it comes out to be 2/3. 2/3 of a year. Now, unfortunately, the decimal for that is 0.6 repeating. So I'm just going to use the fraction 2/3. Whenever you're doing a calculation, you want to avoid, if you can, calculating with a rounded off number. And if I use 0.6 repeating, I'm going to have to round it off. But I can put 2/3 in there and multiply by 2/3. Okay, so it's just a multiplication problem. 4,500 times 0.0525 times 2/3 should be $157.50. Earned in interest. Now, if you actually did this calculation with 0.667, let's say, then it would not be exactly what we were looking for. Even though we're rounding it off to the nearest thousandths, now it's $157.58. That's incorrect. So try to use exact answers whenever possible, and it's almost always possible. Okay, and the last thing we have to do is just a little bit of probability so that we can express it as a fraction and a percent. I should have actually put this at the beginning because we're just changing fractions to a percent. But you should know about simple probability, and probability is a fraction described like this. It's the number of successful outcomes, S-U-C-C-E-S-S. That's the way we spell success. Number of successful outcomes, I'm rounding out of room there, over the total number of outcomes. Total number of outcomes. And since it's like part out of a total, then we can express that as a percent. Total number of outcomes. So if you pick a single card from a standard deck of playing cards, a standard deck of playing cards, you should know something about this, has 52 cards. There's 4 suits, 13 in each suit. Find the probability of picking a diamond. So you have to know, like, how many diamonds are there? Okay, there's 4 suits, diamonds, spades, hearts, and clubs, and there's 13 of each one. So there's 13 diamonds out of a total of 52 cards. If you reduce that fraction down, that would be 1/4. And 1/4 as, if you divide that, that's 0.25. And as a percent is 25%. So pretty simple as long as you know a little bit about probability to turn that fraction into a percent. If you pick a single card from a standard deck of playing cards, find the probability of picking an ace. Okay, so there's 4 possible successful outcomes. That would be because there's 4 aces. There's a total of 52 cards to pick from, so that's 4 out of 52. If you reduce that down, that would be 1 out of 13. And if you divide that, 1 divided by 13 is 0.077, let's say. 0.077. So as a percent, that would be 7.7%. And let's go ahead and do that last one real quick. What is the probability of picking the Queen of Hearts? How many Queens of Hearts are there in the deck? Just 1. How many cards are possible that you could choose? 52. So there's our fraction. If we divide 1 divided by 52, that's 0.019. If you multiply that by 100 to make it a percent, it's going to be 1.9%. So if you're trying to get a royal flush and you only need a Queen of Hearts to complete your royal flush, then the probability is pretty low that you're going to draw that Queen of Hearts. It's not exactly this because, other people have cards and there's fewer cards out there than 52 to choose from. But there you go. Hope we didn't go too fast. There's all of your fractions, decimals, and percents in many different forms. Percent increase, percent decrease, percent tax, and commission. So good luck with those lessons and assignments. I wish you well.